We have one last thing to talk about today, and that is writing polynomial equations. We have factored and solved polynomials, and now we're going to start with solutions or roots, zeros, x-intercepts, whatever you want to call them, and go completely backwards and end with a function that is in standard form. And just to go ahead and introduce one last concept into that, we're going to do with irrational roots when we do it, similar to what we saw in the other one with that square root of 12 that ended up being a 2 square root of 3, plus and minus. And so that leads us into our irrational conjugates theorem. We've talked about conjugates once before when we were talking about complex or imaginary numbers, and we saw that two complex numbers were conjugates if one had a plus in between and the other had a minus. Same thing happens with irrational conjugates. So if we have something in the form of a plus square root of b, and that is known to be a root of the function, then we also have to have another root of the function that's a minus the square root of b. So basically that boils down to radical answers come in pairs, and we saw that in our last example. As I mentioned, we had a positive and negative version of that 2 square root of 3. So we want to write a polynomial function f of x. We're going to keep it simple and make it the least degree. So we're not going to put any x squareds in our factors or anything, just plain x's in our answers. And we're going to have a leading coefficient of 1. Again, keeping things simple. Here are two of the solutions or zeros, 3 and 2 plus square root of 5. But we have to remember that there is a third solution. If we have a 2 plus square root of 5, we must also have a 2 minus square root of 5. So let's go ahead and write the roots that we know we have. We're going to have 3 of them. So our roots are 3, 2 plus square root of 5, and then the one that's not written, but it's implied because radical answers come in pairs, 2 minus square root of 5. And so we have 3 roots, and from what I mentioned earlier, that means that our polynomial must be a third degree polynomial. Remember, the number of roots is equal to the degree of the polynomial. That's always going to be the case. The next thing that we need to remember is that roots and factors are opposites of each other because of that x minus k as the factor. We have to move the k to the other side to get a root. So roots are the opposite sign. Of factors. All right, so now that we've noted that, let's go ahead and write the factored form of our polynomial. So we're going to start with f of x, and that's going to be equal to all 3 factors based on these roots. So we will have x minus 3, remember you have to take the negative. We will have x minus 2 plus square root of 5, so either do double parentheses or the brackets like I did, and then finally x minus 2 minus the square root of 5. All right, so that is changing roots to factors. The next thing that I want to do is simplify this a little bit. I've got parentheses and brackets and I don't like that, so I'm going to go ahead and take this negative sign in each of these pieces and distribute it through to get rid of those brackets. So what I'll have left when I do that is f of x is equal to x minus 3, not going to do anything with that yet, and then x minus 2 minus the square root of 5. Looks a little simpler at this point. And then x minus 2 plus the square root of 5. And so now I have 3 factors, and in order to go back to a polynomial in standard form, I'm going to do some multiplication because multiplication undoes factoring. So this was just a simplify step, and now we're ready to multiply. And I'm going to go ahead and take care of these ugly ones, the ones that have the square root of 5 in them first. And you'll see why once we do it. It's not going to end up as ugly as you might think. All right, so let's say x minus 3. That's just going to come along for the ride now. And we'll start a parentheses, and I'm going to use the distribution method. You can use box method if you prefer. I'm going to take x and multiply it by all 3 of these terms. That's the first step in my distribution. X squared minus 2x plus x square root of 5. Now I'll move to the next term, negative 2, multiply it by all 3. So I will have minus 2x plus 4 and minus 2 times the square root of 5. Finally, moving to my negative square root of 5, multiplying it by all 3 terms, I'm going to have a minus x square root of 5, and then a plus 2 square root of 5, because the 2 negatives will be positive, and then I'm going to have minus, because a negative and a positive here, but minus square root of 5 times square root of 5. So think about that for a second. If I have the square root of 5 times the square root of 5, well, that's the same thing as the square root of 25, because remember, when you multiply radicals, you can combine the things that are under the radicals. So 5 times 5 is 25, and the square root of that is simply 5, so minus 5, and close your parentheses. So this is our multiply step, and we've got a great big old string of terms to deal with here. So I want to combine some like terms as much as I can. So let's do that in the next step. X minus 3 still just kind of coming along for the ride. And now I want to look at the second parentheses. I only see one x squared. I see a couple of x terms, so that'll be a minus 4x. The next thing I come to is an x times the square root of 5. So I want to look for other square root of 5s that have an x on them. And I notice another one, but it's just the exact opposite here. It's a negative x square root of 5, so those are actually going to cancel. The next thing I see is a 4, and that can combine with negative 5, and so that will be a minus 1. And then finally, I see a minus 2 times the square root of 5. So I'm looking for something else with numbers out in front, but a square root of 5 so that I can combine like terms. And I see a plus 2 square root of 5. So these two are also going to cancel. So I'm actually done. And this is much, much nicer than what I did. This was a big simplify step. And now I can take care of these two polynomials and multiply them together. So I'm going to use my same technique of distributing the x and then the negative 3. So I'll have x cubed minus 4x squared minus x, and then minus 3x squared plus 12x plus 3. All right. So now that is another multiply step, and I will simplify one more time. X to the third and minus 7x squared when I combine the x squared terms, plus 11x and plus 3. And this is my final f of x. Notice that it's written in standard form, and that's it.